Hello, and welcome back to AP Environmental Science. Today what we want to talk about is ozone, specifically, because this is a it's one of the 6 criteria pollutants, and it's also really problematic for us specifically here in Dallas. Now, we've talked about ozone before. Remember, when in the very beginning of the year, we talked about stratospheric ozone, right, which is good. Yeah, yay, stratospheric ozone. And that was our ozone shield, and then we also talked about the hole that we're putting in it. So please make sure that you review that. But what we want to talk about right now is tropospheric ozone, which is not good. It is bad. Bad, 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 bad. And so we have... First, I want to talk about just the plants. We've talked about this before. When we talked about pollutants, that there were pollutants that actually were necrotic and chlorotic, right? Chlorotic was the destruction of chlorophyll, or chlorosis is the condition of having your chlorophyll destroyed. But anyway, it is ozone that does this. Ozone is really the big killer of plants. It destroys stuff, right? It destroys cells, and that's bad. Remember, we use ozone, we bubble ozone through municipal water supplies to kill the biologics. Well, that means if there's ozone floating around in the air, it's going to kill the biologics. So it is a horrible respiratory irritant, and it is also causes necrosis and chlorosis in plants. Okay, so it's typically called the summertime pollutant, and that's because you need really hot conditions with direct sun, and we'll get back to that in just a second. And so peak ozone levels are typically going to be during the hot, dry, stagnant summertime conditions, and for us, that seems like that ought to be July, August, September. I apparently don't know the order of months of a year, but anyway, the length of this season is actually going to vary from region to region, but the south and the southwest, and that would be pretty much all of this right here. But the stuff in red, yeah, we have huge ozone problems, and you're going to see that it is actually, in fact, centered around these big cities. Now, you would think that Houston would have a bigger problem, because Houston is a big polluted city. It doesn't, because of this lovely Gulf breeze, right? And so you'll notice that all of the stuff along the coast, for the most part, okay, that's not coast, all of the stuff along the coast, right, and then over here, okay, those are going to be protected from the buildup of ozone by these sea breezes. But then you come back over here and you've got, well, there's Mexico down here, and so that doesn't work out for these guys. So anyway, just remember that it's typically summertime is when you have your highest concentrations, but for us, we pretty much get high concentrations lots of times during the year. Okay, here's your first question. The western pine beetles that killed numerous ponderosa and Jeffrey pines in the Sierra Nevada mountain range of California were assisted by drought in the Central Valley, mineral deficiencies of soil, wildfires, ozone from cars and industry in the Central Valley and San Francisco Bay Area, and clearing of forests for vacation homes. This is something that we talked about a little bit when we talked about forestry, but there are lots of forests around the world that are dying for different reasons. And we've talked about acid rain, we've talked about shifting water patterns, right, precipitation patterns, and all these things. This situation was caused by what? Well, all of these things actually do happen. This particular situation was exacerbated by ozone. Ozone is really serious. Drought is serious. Mineral and nutrient deficiencies, those are serious. Wildfires, those can actually be helpful, but if they're too bad, they're serious. And then, of course, clearing forests would be cutting them down, right? So that's obviously a problem. But in this, like I said, in this particular instance, ozone was really the big kind of key factor that caused these trees to die. Okay, and here's an interesting fact. If you increase the atmospheric ozone, like tropospheric ozone, by just 20 parts per billion, and remember parts per billion is very tiny, you actually see around an 80% increase in school absences, right, for people who are suffering for respiratory conditions. Okay, so that is going to look like all kinds of other viruses, but in fact it's going to be about pollutants. Okay, and then one of the things that you see over major cities, right, time and time again, is this haze that just hangs over the city, right? Blah. Oh, and by the way, this is Italy, and this is Los Angeles, just as an aside. Okay, so here's your next question. You'll notice that one of those smogs, the picture on the right, was brown, whereas the other one was gray. Okay, that means that you were looking at two different pictures of two different kinds of smog. The one on the right was photochemical smog. So the question becomes, what gives photochemical smog its brownish yellow color? Well, argon and carbon dioxide are inert, so that means it's either sulfur dioxide or nitrogen dioxide, and it is in fact the NOxes. The NOx family is what gives it that really gross brown-yellow color, okay? Sulfur dioxide gives you the fun acid part, and of course so does nitrogen dioxide. But let's really talk about what is the difference between industrial smog and photochemical smog. It turns out that industrial smog is from industrial stuff, right? The burning of coal, all of that. And so what it is filled with are going to be your SOxes, carbon monoxide, carbon dioxide, particulates, okay? The secondary pollutant is going to be sulfuric acid that you find in that. And of course you're going to have asthma, eye problems, heart failure, premature skin aging, emphysema, increased susceptibility to disease, because anytime you have health problems, opportunistic things can come in and attack you, okay? Good examples of cities with bad industrial smog are London and Beijing, okay? Now, photochemical smog is different. Photochemical smog is going to be your nitrogen oxides, that's that brown part, the VOCs, and the secondary pollutants are going to be ozone and PANs, right? Well, we know how sulfuric acid gets made, sulfuric acid, but how do ozone and PANs get made? And again, we're focusing on ozone. Hey, if you look at this list, it's exactly the same as this list. Neither smog is better, is the point here, right? They're both bad. Los Angeles and Mexico City are two examples of cities with really, really bad photochemical smog. Okay. Here's your next question, though. Which of the following countries currently has the worst problem with industrial smog? Well, we're going to leave Canada off the list because they don't have a whole lot of people comparatively. So their population density is a little bit lower. So they have some lower pollution issues than, the other three on this list. In the United States, our big smog issue is photochemical. Okay, we have bad photochemical smog. We'll come back to that in a second, right? England and China both have industrial smog. England has done a lot to clean up its atmosphere, right? Because remember, they burned lots and lots and lots of coal for a very long period of time since the Industrial Revolution. So they still have industrial smog. But recently, over the last several decades, they've done a lot to clean it up. China, on the other hand, is still struggling because they are still developing. They're still burning lots and lots of coal. Remember, 70% of their electricity comes from coal, and then there's always the heating and the cooking and the, personal use and blah, blah, blah. But when you're talking about 70% of electricity for over 1 billion people, that's a real big problem, right? And so China is the answer to this question. Okay, now let's talk about this photochemical smog. It's different, right? Now, ozone is a secondary pollutant, right? And sometimes you'll see it as tropospheric ozone, sometimes you'll see it as ground level ozone. But basically what you have are these VOCs and these nitrogen oxides, and I've put both these little slides in here, showing that you have the sunlight, right, which is the catalyst for the NOxes and the VOCs to undergo a chemical reaction that produces ozone, O3, okay? And so here you've got a lot of this is going to come from cars, right, trucks, and a lot of this is going to come from refineries manufacturing, okay? So, ozone, huge component. Nitrogen oxides, VOCs, huge components in smog. Okay, now, this I put in here just because I really like this picture, and it shows you all of the little parts, more or less, of the ozone, and so, the formation of ozone. Anyway, so I'd like you to check this out, right, and read it. But remember, you need to have sun. So ozone levels will be highest in the afternoons, right, because you've had sun all morning. That's when it's hottest, okay? And so it's not really a nighttime issue. Ozone levels rise and fall throughout the day. Please remember that. Okay, here's your next question. Ozone is a blank pollutant from blank sources. Well, we know it's made in the air, so it's not primary. it's secondary because it is from chemical reactions from primary pollutants. Now, it is both stationary and mobile. You have factories, right, industry, but you also have cars, trucks, trains, airplanes, all of those things. So the answer is 4. Okay. Now, one of the things that really exacerbates the ozone problem are temperature inversions. Now, temperature inversions oftentimes occur in the winter, and this is how you get some of the really bad winter ozone. We actually have bad ozone levels in the winter as well as in the summer, and that's because we actually do get a lot of temperature inversions. This, of course, is going to be worse in places that are surrounded by mountains where you get this cold, still air. And so our problems with ozone are not nearly as bad as, say, LA, who has this bowl-shaped kind of thing going on. But temperature inversions don't just lock in ozone, they lock in everything that's there. And so you get this urban heat island effect, right? You get this heat island effect, which makes this rising warm air. Now, normally, this is normal, the warm air is going to go up as the troposphere gets cooler and cooler and cooler, so this just continues to rise. However, sometimes you will get this weird warm layer that occurs between two cooler layers. And what that means is this cooler air, even though it is warm enough to rise up to this level, it's not warm enough to punch through this. And so this acts like a little cap. So temperature inversion essentially is this little warm air cap that sits over the city, preventing any sort of air movement from going on. So, just to review, a temperature inversion occurs when warm air rises, a layer of warm air is sandwiched between two cooler layers, too much pollution is produced, a layer of cold air is sandwiched between two warmer layers, or a warm sandwich is left out in the cold. It's not 5. Okay, remember you have this layer of warm air that acts like a cap. The answer is 2. Okay, that was just for review. So, where are the worst polluted areas? It's going to be all the big cities, and the big cities in the south. Even though these guys have tons of pollution up here, and they are polluted and all this good stuff, ozone, the components for ozone, the heat, the sunlight, the NOxes and the VOCs, they're going to be in your southern cities, okay? Now, we talked about how Houston has less of an ozone problem than Dallas, but Houston has all of the refineries and all of that stuff and a lot of industry, and so they have a whole lot of other problems that we don't have, right? And so that sea breeze kind of helps them with the ozone, but it really doesn't help them considering how much they're actually putting into the atmosphere at any given time. So, okay, now let's talk about a catalytic converter. The way to prevent the NOxes and the VOCs and carbon monoxide actually from exiting your car when you are burning, or any vehicle when you are burning fuel, is to have a catalytic converter. And the catalytic converter, like if this is your engine and here's your little muffler and your exhaust pipe, yay, the catalytic converter is pretty much somewhere kind of like under your driver's seat, right, passenger seat, somewhere around there. So what does it do? Okay. First of all, the catalytic converter has some stuff inside of it. Here's a nice other more complicated picture. But basically, the exhaust gases from the burn, right, the VOCs, the hydrocarbons, and predominantly VOCs is what we're concerned about. The carbon monoxide, the nitrogen oxides, they will undergo chemical reactions in here, and we have the chemical reactions right here. Please know these 3 major reactions. Okay, please know these 3 major reactions right here. And then what you're going to get out is water. Yay, that's why your tailpipe drips sometimes, by the way. Carbon dioxide and just nitrogen. All of these things not toxic. CO2 is a little bit of a problem for the greenhouse issue, but it is not a pollutant, okay? And then this is just a little bit more of a detailed drawing about what's happening, okay? And this actually, these are the things inside your catalytic converter. And by the way, it is this right there, the platinum, that makes catalytic converters such targets for getting stolen, right? There are all these rings that go around cutting people's catalytic converters out, and you'd ask, well, why would they do that? It seems like a lot of trouble, although apparently it's not that much trouble. You just slide underneath, hack up the pipes, and take it away. But don't do that. Platinum, right, is a very expensive metal, and you can make a lot of money that way. So, and that's one of the reasons it's so expensive to replace a catalytic converter. Anyway, okay, So the average vehicle in the U.S. today, compared to 1950, produces less pollution, is driven much more, weighs much less, is driven much faster, or all of the above. It is actually all of the above. Remember from our pollutants conversation, we know that they produce less pollution. Think about all the driving that we do. There are more cars, and we drive them more. I mean, think about suburbs and commuting and stuff like that. Now, we do have cars that weigh a lot less, and this is very helpful because it means you need less fuel to move them. Okay, think about inertia that you learned about in physics. And then driving much faster. There is a certain speed. Now, obviously, guys, if you're really, really speeding, you're going to burn a lot of fuel. But there's this, like, maximum speed. That's why they have speed limits. But on the highway, you have those highway mileages. Once you get up to this nice, like, normal highway speed, it's very efficient. Now, that is not efficient on side streets because you're speeding up and slowing down and speeding up and slowing down and speeding up and slowing down. And that uses way more gasoline. So, message here is twofold. One, drive safely, right? Drive the speed limit. And two, you do want to drive the speed limit because it also saves gas. Okay, last thing, I put this in here just for you guys. It's a nice little concept map that talks about good ozone versus bad ozone, and then has some of the major concepts. So if you like concept maps, this is for you. If you have any questions about ozone, please let me know in the next class, and I will see you next time. Thanks for listening.